Hi everyone. I wanted to solve a couple of problems for Newton's second law, which is basically force is equal to mass times acceleration. I want to point out two things in here. One is the force. When you say force, F is equal to ma, right? Force is net force. So if you have multiple forces in a system, this force actually needs to be the net force, meaning that the total of all the forces on the system. And don't forget that force is a vector, therefore you need to pay attention to the direction of the forces you have on your system. And the second point is that mass needs to be total mass. So if you have more than one object in your system, then you need to add all of the masses you have that is being accelerated with the same rate, right? So otherwise they wouldn't be accelerating with the same rate. So the first example I wrote here is a 2 kilogram box being dragged with a 10 Newton force toward right. And as I said before, I always follow the XY coordinate system notation, meaning that toward right is positive and toward left is negative for me. And in this first example, I use only just one single force and one single box. So it's the simplest version you can ever solve with a force formula, which is basically F is equal ma once again. Therefore, you apply your values, your force is 10 and your mass is 2. You solve for acceleration. So this box is going to be accelerated by 10 divided by 2, 5 meter per second square. So that is the acceleration created by this force you apply to it, right? So naturally, the acceleration is in the positive direction as well, because we have only one force that is dragging the box to it, right? So the acceleration it's going to create is going to be naturally to it, right? In the second example, I have the same box, same force I apply, but this time I put 4 Newton friction on it. And one thing that is important about friction is that it always opposes the motion. So the direction of friction is always in the opposite direction to the motion because it tries to stop the motion. That's the nature of friction, as you well know. So in this case, because you have multiple forces, once again, the force in this formula needs to be net force, and toward right is positive, toward left is negative. So when you add these two forces that are in opposite direction, what you get is that 10 plus minus 4, because 4 is toward left and left is negative, your net force is 6 Newton instead of 10 now, okay? So that is going to be equal to 2 times A, and you will solve for A as 6 divided by 2, so it's going to be 3 meter per second square. So you can compare these two numbers and see that how actually friction is slowing down the object, right? Again, friction always opposes the motion. It tries to stop the motion, and as you can see from the acceleration value decreasing, that is the case. So the third example I wrote was two boxes that are attached together with a string, and you're trying to pull them toward right with 20 Newton, and here I don't use any friction again. So in this case, you have one force, but you have two masses. So force is equal to 20, and you have total mass of 2 plus 4 accelerated together because they're connected. Therefore, your acceleration in this case is going to be 20 divided by 6. So it's going to be 3.33. It goes 333. I will just to keep 2 digits. And test or anything, if there is a designated number of digits you need to keep, read the questions carefully, follow the instructions. Otherwise, keep at least 2 digits to make sure that you're getting all the details you should. Because if you remember, you have some percentage of error allowed, and writing your results as precise as possible is the key to get the full credit. So here what I want to mention is that what you see here is that this 20 Newton is applied onto these two boxes, but it's been shared by these two boxes so that they accelerate together with the same rate, which is 3.3. So if a question asks you like what is the force on the two kilogram box, let's number them 1 and 2. So the box 1 is 2 kilogram. So you can basically apply the force is equal ma formula, Newton's second law, to the whole of the system like I did here, right? or the individual parts of the system as well. So in that case, you're going to use the mass of this part of the system, which is 2, and the acceleration is common, as I mentioned. They have to accelerate together to be able to move together, so it is 3.33. So you get 6.66 Newton applied onto this box 1, and if you call this box 2, what is the force on box 2? Then you're going to use the mass of that box, which is 4, and acceleration again is common because they're moving together, accelerating together with the same rate. It has to be, and that is going to be 4 times 3.33, so it's going to be 13.32 Newton. So basically 4 kilogram box is getting the 13.32 Newton to accelerate with 3.33, whereas box 1 gets 6.66 Newton of the total force. So when you add these two, you get actually, you're not getting completely the same as 20, which you should, but I'm doing rounding of, as I said, this is actually 333 like infinitely, and so that's why I'm not getting exactly 20 Newton, but when you add these two, if the numbers were chosen perfectly fine, I mean better, then the total force F1 plus F2 should be equal to the net force on the system, which it's close enough, I think, so it shouldn't bother you. Let's add one more complication to this picture, which is friction. So in example 4, let's have the same boxes, 2 kilogram connected to 4 kilogram and being pulled by 20 Newton to the right, the applied force. And let's say this one has 4 Newton friction and this one has, so let's say this is friction 1 and number 1, number 2, friction 2, that is 8, let me choose it to be 6 actually, 6 Newton. So, so you have 3 forces on your system in 2 boxes. So what you need to do is that applying the Newton-second law to the whole system requires you to add all of the forces, right? Again, toward right is positive, toward left is negative. So the net force in this system is going to be 20 plus minus 6 plus minus 4. So that is going to be 20 minus 10. So it's 10 Newton is the net force on this whole system. And that is going to be accelerating both of your boxes with the same rate. So it's going to be 2 plus 4, the total mass, times acceleration. So if you solve for A, you're going to get A is equal to 10 divided by 6, which is going to be 1.66666. Again, infinite digits. I'm going to round off to 6.7 meter per second square. So as you can see, again, once more, your acceleration value dropped because of the friction, applied friction here. So once again, if a question asks you, what is the net force on number 1, the box 1? What is the net force on it? Let's go with F1 because it's the box 1. You're going to apply the Newton's second law on this specific part of the system, which is box 1. So mass of the box 1 is 2, and the acceleration of it is 1.67. Therefore, you get 3. What is that? Give me 1 second. 2 times 1.67 is 3.34. So Newton is the force on the first box 2 in order to accelerate it with 1.67 acceleration. What is the net force on box 2? Let's call it F2. You need to apply the Newton's second law individually to this box this time. The mass of this box is 4, and the acceleration of that box is 1.67 again. Let me draw my 7 like this and put them in parentheses. These are the accelerations, right? MA. So you get 6.68. So you get 6.68 Newton accelerating box 2. So if you look at the numbers, you add these two, again, you should be getting exactly 10 Newton, which we are not getting exactly because of the approximation I made here, because this was actually 1.66666. I did approximate it to 1.67, kept 2 digits, and that approximation basically is showing itself in the fact that when we add these two numbers, we don't get exactly 10, but we should have, because that's the net force, and this net force is accelerating these two boxes together with the same acceleration, 1.67. So I hope this helps for this kind of questions in Newton's second law. Have a good day.